We were in section 4-3, and we're going to start off with problem number 36. So I've got the fourth derivative of x plus 13x, the second derivative, plus 36x is 0, and I know that I have initial conditions x at 0 and x prime at x double prime at 0 are 0, x prime at 0 is minus 2, and x triple prime at 0 is minus 13. So the chances of us being able to write down the Laplace transform of the entire thing are slim and none to get it right the first time, but we will do our best. Okay, so are we ready? Laplace transform of what's on that side. Okay, so s to the fourth x of s minus s squared, the function at 0, s cubed, the function at 0, minus s squared, the function at the first derivative, minus s, the function at the second derivative, which is 0, minus the function at the third derivative, which would be plus 13, plus 13 times the second derivative, s squared x of s, minus s, the function at 0, which is 0, minus the first derivative at 0, which would be a plus 2, plus 36 x of s is equal to 0. Okay, so I've got s to the fourth plus 13s squared plus 36 x of s is equal to minus 2s squared. I got a 13, I got two more 13s for 39, then I've got a 36 for 75, so I got a minus 75. X of s is minus 2s squared. Well, that's probably not going to be convenient. We're probably going to have to keep it minus. Otherwise, we're going to forget that minus sign when we do the partial fraction thing. X to the fourth plus 13s squared plus 36. Okay, now assuming that we haven't made a mistake yet, we can proceed. Let's see, is that guy going to factor 9 and 4, right? So x of s minus 2s squared minus 75 over s squared plus 4, s squared plus 9. How convenient that we remember our 9th grade algebra. All right, now we're going to have to do a partial fraction and say x of s as plus b over s squared plus 4 plus cs plus d over s squared plus 9. Okay, we'll put it under a common denominator again. S squared plus 4, s squared plus 9, and let's see, I got a s cubed plus 9 as plus bs squared plus 9b, and I did it again. I ran out of room. So we'll move that guy down, see if I can only get him. Move him down. Okay. Plus cs cubed plus ds squared plus 4cs plus 4d. Okay. Then I look at the s cubed term, and I find that a plus c has to be 0. I look at the s squared term, and I see that b plus d has to be minus 2. And I look at the s term, and I find that 9a plus 4c, 9a plus 4c, I think that's equal to 0.
Yep.
And then I have a unit term, and the unit term would be 9b plus 4d, 9b plus 4d is equal to minus 75. Okay, well I have 4 equations, 4 knowns, but really I have 2 sets of 2 equations, 2 unknowns. So I'll solve for A first. A is going to be very interesting. I think A has to be 0 and C has to be 0. Because if A plus C is 0, then A is minus C, and then minus 5C is 0, so C has to be 0. If C is 0, A is 0. So it looks like that's the case. So now we're looking down to solve for B. B is equal to minus 2, 0, 1, 4, using Kramer's rule, divided by 1, 9, 1, 4. 1, 9, 1, 4. Okay, so I got minus 8 over 4 minus 9, which would be minus 5. So B is 8 over 5. And if B is 8 over 5, then C, D. If B is 8 over 5, then D would have to be minus 18 over 5.
Shouldn't it be negative 2 to negative 75? So negative 2, 0.
Negative 2 minus 75. Yeah, that would make a slight difference, wouldn't it? Yeah. Yeah, that's a good place to catch that error too, by going on someplace else to catch it. 8 minus 8 plus 75 would be 67. 67. Okay, so B plus D is minus 2. So D would be minus 77 over 5. Alright, now we'll check that. If I have, see if I can see both of those at the same time. Alright, so if I have 9 times 67 over 5 and I add 4 times 77 over 5 with a minus sign, I don't get minus 2. Or minus 75 for that matter. Oh, there's a minus sign sitting here. Yeah, that, okay. So there's a minus sign sitting there, which of course changes this to not to minus 67, but it has to be 57, right? Positive 57. Positive 57. Does that get me 75 now?
Yeah.
Okay, we'll take your word for it. Excellent. So that means that x of s is equal to minus 2 over s squared plus 4 plus, not minus 2, minus 67 over 5 minus 67 over 5 plus 57 over 5 s squared plus 9. Okay. Now, we want a 2 on top of this guy, and we want a 3 on top of that guy. I know that for a fact because I'm looking at number 8. So if I look at number 8, in my Laplace transform table, I know what I want on top. So in order to have a 2 on top, this is going to be minus 67 over 10 to s squared plus 4. And in order to have a 3 on top, this is going to be 57 over 15, 3 over s squared plus 9. Okay, at that point, we would take an inverse Laplace transform and say x of t equals minus 67 tenths sine, is that a sine? Yeah, sine 2t plus 57 fifteenths sine 2t. Okay, that it might be reasonable. We'll open up Maple and see if Maple thinks that that's a reasonable answer or not. Yes, it would be 3t on the second one. So it's definitely not reasonable because it's 3t. Now this looks weird because normally you'd expect to see a sine of something and a cosine of something, and so that being the case, but Maple isn't going to let us down. It doesn't matter how hard the problem is. Well, it might matter how hard the problem is, slightly. But to the extent that we can put it into Maple correctly, we can. What in the world are you doing? Why are you taking so long to do something that should be easy to do? Kernel correction not available? I have no idea what that means, but it looks weird. Let's try it again. There is no differential equation solver in Maple anymore. Okay, be that way. Alright, I just won't poke on things. Okay, well, while we're waiting for Maple to come up, we'll look in the back of the book and see if we have the right answer. 4-3, number 34. It says, yeah, oh, that's 35. That's 44. No wonder. 34. Now I've got 1/2 sine 2t, 1/3 sine 3t. So now the issue is, are those things really 1/2 and 1/3? They sure don't look like it. And it certainly doesn't look like it's negative. Oh, bummer. Alright, so moving back up. What did we do wrong? Now it could be that the grad student made a mistake. S to the 4th x of s, the function at 0, which is 0, minus the function at first derivative times s squared at 0. Okay, so that's correct. And then the third derivative, that would be correct. 13 s squared and 2, so that's a minus 2, so that's correct. Alright, so we did everything okay there. Okay, yeah, okay, 1336 minus 2s, and we decided this is 75, so there's 39, because I have 3 13s. 39 plus 36 is 75 with a minus sign.
Okay.
Yep, I think it is.
Why did you have 36 since it's part of the x of that?
Oh, yeah, good point. Alright, so this is really a 39, not a 75. This is a 39. I think it's because it's too late in the day. What do you think?
I'll agree.
39. Alright, so that's 39, that's 39. This becomes 39. This becomes 39. Okay, change the black. This becomes a 39. Now, minus 8, and it's a minus 39, plus 39 is 31, right?
Mm-hmm.
So 31, and this is still minus on the bottom, so minus 31 for the whole thing. Okay, and so that's minus 31. In order for, so D would have to be 41. No, it wouldn't have to be. It'd have to be 21. D would have to be 21, and then I add it to that guy. Okay. Alright, looking better. Everything's fine now?
Yep, that checks out.
Okay, so this is going to be 31. This is going to be 21. I need a 2 there. So this is going to be 31 over 2. I don't see how that's going to be a 1/2 though. And this is going to be a 21, a 7 over 5. This is going to be a 7 over 5. I need a 3 there. That'd be a 6 over 5. I'm not sure what it is. We'll call it a 21 over 15. 2 times that, 3 times that. Okay, I still don't have a 1/3 or a 2/3. I'm supposed to have a 1/2 and a 1/3. I still don't have it. Let's open up our spreadsheet. Let's see what Maple thinks. Maple still isn't thinking. We'll open up our spreadsheet to do multiple equations, multiple unknowns, see what it thinks. two equations, two unknowns. Okay, 1 and 1 is minus 2. 1, 1, minus 2. And the other one's 9, 4, minus 39. 9, 4, minus 39. Minus 6.2, 4.2. That still isn't going to get me what I want. That still isn't going to get me what I want. Because this is 6.2 sitting right there. And this is 4.2 sitting right there. So that's exactly the same thing I had before. And Maple is still not cooperating. Control Alt Delete. See if we can force Maple to cooperate. Okay, we forced Maple to shut down. Now we'll open it up. See if it'll cooperate the second time. Tools, assistance, differential equation solver. Oh, much better. Alright, so x of t, and I need a fourth order guy, and I need a second order guy, and I need a zero order guy, and the fourth order is by itself, and I get a plus 13 times, and then I get a 36 plus 36 times, and then I get an equal 0. Oh, bummer, I put it in the wrong spot. Equals 0. Okay, done. It almost went away. I thought I didn't have it. Conditions. X at 0 is 0. X prime at 0 is 2. My 2? There's a 2 there, really?
You said -2.
There's a 2 there.
Mm-hmm.
We're not solving the same problem. Alright, well that's a horse of a different color. Now we know what the problem is. That's a positive 2 sitting in problem number 34. Yep, sure is. So this is a positive 2. That makes this a negative 2. If that's a negative 2, then this is going to be a positive 13. Positive 13, and if that's a positive 13, then this is a positive 13. That's a positive 13. Okay, and this is going to be a positive 13. That's a positive 13. So now I've got 8 minus 13 is 5. So this becomes a minus 1. And if B is a minus 1, B is a minus 1, then D is a -1. You're right. But that can't be. This is -13, which makes this positive, makes this positive, which makes D 1. You're right. So D is in fact 1. -2 making D 1. Because this is -8 minus 13. Wait a minute, -8 minus 13.
But that 2 is positive. So that can be negative.
No, this 2, oh.
Because that's on the change.
Oh. This 2 here is negative, which makes him positive. Yes, I agree, which makes this guy positive. So now I get my same answer, except now if this is positive, then D is still 1. Okay, so D is 1, B is 1. Okay.
They'll change because you had it divided by negative, so negative.
This guy's 1, that guy's 1. This guy's 1/2. This guy's 1/3. And I've got one-half, 1/3, 1/2, 1/3, and were either of those guys negative? I hope not.
No, they're both negative.
Nope, they're both positive. So the answer, this checks with the back of the book. Excellent. Check back of book. All right. Well, that was fortunate. Number 36. Number 36. Pay more attention this time, Nixie, so we don't mess it up early. I know. We're really hosed without Karen here, I know. No, we're not. We should be able to do it without somebody else here. No. Now, the issue is, can I write down the initial conditions correctly? Well, everything is 0. You think I'll mess that one up? I think I can remember these initial conditions this time and not mess it up. Everything equals 0. Okay, so I take the Laplace transform of everything. S to the 4th x of s, 2 s squared x of s, x of s, 1 over s minus 2 from number 7. Number 7. All right, so I got s to the 4th, 2s squared, 1 x of s, 1 over s minus 2. I got x of s, 1 over s minus 2, s squared plus 1 squared. Okay. I do a partial fraction. S of x. A, s minus 2. B, s squared plus 1. C, s squared plus 1 squared. So when I have the same guy in the bottom, I don't go, oh gee, that's s plus c though. And this would have to be c, d, s plus e. Oh, looks like I'm heading for 5 equations, 5 unknowns, and I don't have a solver for that. Oh well. Can't have everything. So we put them all underneath the common denominator, leaving plenty of room on the top. Okay, so this is going to be a(s squared) plus 2as plus a. No, it's not. I just know that's not right. Don't you know that that's not right? Yeah. So a, we'll leave room, so s to the 4th plus 2as squared plus a. Okay, so that's what this guy is. Plus. Now, we need s minus 2 times s squared minus 1. So that's s cubed minus 2s squared plus s minus 2, right? Okay, so I got bs to the 4th minus 2bs cubed plus bs squared minus 2bs plus cs cubed minus 2cs squared plus cs minus 2c plus d. I still ran out of room, even though I left enough room so I wouldn't run out of room. I still ran out of room. Wouldn't you know it? Okay, so I'm going to bring that guy down. All right. Okay, now I've got ds squared minus 2ds plus es minus 2e, leaving a whole lot of room for interpretation on that one. So you think I got it right? All right, I'll look at it again. Okay, I think I got that one right. If I did this right, which it looks like I did, bs to the 4th minus 2s squared 2bs cs cubed 2c, and then this guy. No. This is ds squared minus 2ds plus es minus 2e. Okay, so we corrected the only mistake we made. Yeah. So the s to the 4th term, I've got an a, I got a b. And the s cubed term, I've got a minus 2b, I got a plus c, okay. The s squared term, I have a 2a, I got a b minus 2c plus d. The s term, minus 2b plus c minus 2d plus e, and then there's the unit term, a minus 2c minus 2e. Okay, are we confident with that? Maybe. Okay, now the s to the fourth term has to be, where is it? Everything's over 1. Everything's 0 except the unit term. Yeah, everything's 0 except the unit term. Okay, is equal to 0, is equal to 0, is equal to 0, is equal to 0, is equal to 1. Okay, we can live with that. Can we live with that? Okay, now, if we let A equal minus B. Okay, so we're going to do that. And if we do, then we're going to have 4 equations, 4 unknowns, and we can use our 4 equation, 4 unknown solver. Okay, so I got 2B plus C is equal to 0. I have B minus B minus 2C plus D is equal to 0. I have minus 2 minus 2B plus C minus 2D plus E equal to 0. And I have minus B minus 2C minus 2E equal to 1.
Can you make minus 2B in your second equation?
Not this guy here?
Yeah, because it's 2A, and then plug in the negative B.
See, here's minus 2B plus B, making it minus 1B. Okay. So we're happy with that? Okay. Now, the issue is, can we see that at the same time looking at our 4 equation, 4 unknown solver? That's the issue. Okay, so this is 0. No, it's not. That's minus 2, 1, 0, 0, 0. Second equation. Minus 1, minus 2, 1, 0, 0. Third equation. Third equation. Minus 2, 1, minus 2, 1, 0. Last equation. Minus 1, minus 2, 0, minus 2, 1. Oh, that doesn't look good. That just doesn't look good at all. Alright, so A is 4/10, which is 1 over 25, right? So A is 1 over 25. B is minus 1 over 25. C is 8/10, 2 over 20. I knew that. Minus 2 over 25. D is minus 1/5. Minus 1/5. And E is minus 2/5. Well, that doesn't look that bad. Does that look that bad? That doesn't look that bad. Alright, so now we have to remember what our equation was. So x of s 1 over 25 s minus 2 plus minus 1 over 25 minus 2 over 25, and s goes there, s squared plus 1, s squared plus 1, plus minus 1 over 5s minus 2 over 5 divided by s squared plus 1 squared. Now, the issue is, do we have an s squared plus 1 squared guy? And yes, we do. Okay, so number 21 and 22, 20 and 21 are going to help us out there. Okay, so I look at this guy, and he looks like number 7. I look at this guy, and he looks like number 10 and number 8. Number 10, number 8. And I look at this guy, and he looks like numbers 20 and 21. 21 and 20, maybe. Alright, so that's what we're going to do. We're going to manipulate it to make them look like those things. So this is going to be, I want a 1 on top, so this is going to be 1/25, 1 over s minus 2. Now, I look at 9, look at 8 and 10, 8 and 10. Okay, if I bring a 25 out, okay, so I'm going to have minus 1 over 25, and then I'm going to have s over s squared plus 1 plus 2 times 1 over s squared plus 1. Alright, so that gives me straight lines into 10 and 8. Now these guys over here, 21 and 22, I need a 2k, I need s squares on top of them. I don't have any s squares. Wow.
Just on one, or just on one.
Yeah, but I got an s. I got an s up there. So 21 requires an s squared, and I only have an s. How am I going to get around that? There it is, 18. I'm going to look at 18, and I'm going to look at 18 and 20. So I'm not going to look at those guys. I'm going to look at 18 and 20. Okay, so 18 requires a 2ks. K is 1, so I need a 2s on top. Okay, so if I go and take out a minus 1/10, I can have a 2s there. S squared plus 1 squared. Now, if I do that, okay, that's number 18. Okay, so I got a 2s there. Now, what does that leave over here? That leaves a 4 sitting here, right? So 4, yeah, that leaves a 4 sitting there. Okay, so I'm looking at number 20. I have a 4, but I only need a 2. Okay, I only need a 2, so I'm going to go plus 2 2 over s squared plus 1 squared. Okay. Now I'm going to take the inverse Laplace transform of everything I see. And I'm going to have x of s equals 1/25 e to the 2t minus 1/25 cosine t minus 2/25 sine t minus 1/10 t sine t sine t minus 2 over 10, also known as 1/5. Number 20. This is number 20. 2 over 5th. I'm going to have sine t minus t cosine t. Okay, that looks nice. That looks nice. Final answer time. Final answer. X of s equals 1/25 e to the 2t. Now, I've got a cosine there. Okay, so that'd be minus 1/25 cosine t. I've got minus 2/25 here, minus 2/10 there. So 2/25 plus 2/10 give me 7/25. Okay, so I have minus 7/25 sine t, and then I've got a minus 1/10 t sine t, and a minus 2/10. We can write that as 1/5, I suppose. Minus 1/5 t, and it's going to be positive because this is negative t cosine t. Well, I guess we can just go home. No reason to check that, right? I mean, it looks perfect. I can't imagine how that can be any answer other than that. That was 36, was it?
Yeah.
36. Okay, they have a 1/50. Okay, so they got 1/50 times 2 of this, which makes that correct. And then they have a 1/5 t cosine, making that correct. And then they have a minus 1/25 cosine, making that correct. And then they have a minus 10 t sine, making that correct. And over here they have 14/25 with a minus sign, 14/50, which is 7/25. Wow. Check. Back of book.
That was a fun one.
You like that one? Was that okay? That was okay?
Yeah, it's not bad.
All right. So let's see. I have a 3:45 meeting I should go to. You think I should attend it, or should I do another problem? Okay.
You.
Huh?
So that's up to you.
I mean, the whole purpose of having meetings is to get out of class, right? So it'd be a waste of time to have the meeting and not get out of class. Now, we did 36,
Yeah.
and we're supposed to go to, well, I was supposed to do 39, but that doesn't seem that much of a bother. Okay, so the plan is to do the Chapter 4 test in our next class period.
Okay. Are you gonna? And these videos are gonna be posted.
Oh yeah,
Okay.
yeah. Assuming that this guy